We are working on 2.4 example 5. And I love example 5 because this is actually geometry and it's kind of similar to types of problem you guys are going to see next year when you're in geometry, where you have these shapes and you have to figure out area and perimeter and determine what x's are based on those formulas. And so if you don't remember, area of a rectangle is length times width, but area of a triangle is 1/2 times base times the height. So those formulas are different. And it's saying here in this problem, based on these shapes here, that the area for each of them is the same. So this is length times width. And then this one is 1/2 base times height. And so this, when I put them together, is 5. And then the other times x plus 4. And then the other one is 1/2, 12 times 2x minus 6. Based on the formulas and based on the shapes. And they say that the areas are equal. So even though their shapes are different, the inside area of them is the same. In geometry, we call that congruent. So they're congruent to each other. And so what you would do in this situation is you'd have to know the formula of the triangle and formula for area of a triangle and formula for area of a rectangle. You'd have to know those offhand. You'd have to recognize where those lengths are for you to plug into the formula. And now you also have to know the algebra part in order to solve for what you need. So in this situation, they want us to solve for x. So because they say in the prompt that they are equal to each other, that's why we have the little equal sign here. And then we have both formulas on either side. Then you have to solve. And 1/2 times 12, I always tell students 1/2 is super easy because it's just half. What's half of 12? 6. So that means 6 goes here. And now they're exactly the same, but let's go ahead and follow our steps. The first thing we need to do is go ahead and handle these distributions, okay? So for this one here, let's distribute on the left. We have 5 times x, which is 5x, and 5 times 4, which is positive 20. On the right side here, I have 6 times 2x, which is 12x, and then 6 times negative 6, which is negative 36. Now, the book does this a little bit differently than I do. They went ahead and moved the numbers first. That's okay, but I'm going to show you why I'm not a fan of that sometimes. And that's because maybe you do that first, but now you're going to be stuck with a negative x negative variable. Now in this situation, they don't do that, so I'm not going to be too picky, but I always say move the variable first so you can make sure you pick the side where it's positive, okay? But it's not necessary. Everybody could solve this problem a different way. So let's go ahead and do what they do. So what they do is they move the numbers first, and so they move the negative 36 over to the left by adding 36. And then you get 56, which is here. Then they move the 5x to the 12x, and that means how do you get rid of 5x? You minus 5x, minus 5x, and 12x minus 5x is 7x, and so you have the 56 that you already got equals 7x, and that's 7 times x. How do you get rid of that? You divide, so divide both sides by 7, and you get 8. And then you could go ahead and just plug it back into the problem and you should get the same answer. So let's go ahead and do that really quick. So we have 5 times 8 plus 4 equals 1/2 12 times 2 times 8 minus 6. So go ahead and try this out on your own to check and see if it's correct. All right, let's go ahead and work this out. So 8 plus 4 is 12. 5 times 12 is 60. So that's what we're checking on the other side. Over here, 1/2 of 12 is 6. So this turns to 6. And then I could go ahead and say 2 times 8 is 16. And 16 minus 6 is 10. And 6 times 10 is 60. So we are correct. All right, let's go ahead and take a look at this. It says find the value of x so that the figures have the same area. This one is a little bit trickier because we have to create it. But again, this is great practice because you are going to see this next year in geometry. So first thing we have to do is understand that luckily for us, the formulas are the same. Area in this situation equals length times width. This is my length, this is my width, this is my length, this is my width, and I'm going to go ahead and proceed from there. So let's start with the triangle, or not the triangle, the rectangle on the left side. So on the left side here, we have x and w, and length times width means that we're going to multiply them together. Now, one thing I am going to point out is that you're not wrong if you do this. Whoops. That would be wrong. You're not wrong if you do this, but it's not seen as proper. So even though I labeled this as W and W is second here, I'm going to put the 10 in the front just because that's what's considered proper. But again, you're not wrong. Either way, that is 10 times X. Okay. And then I'm going to put the equal sign and do the other side. Now this is a little bit different. Okay. So I want you guys to pay attention. First of all, I have this W here that just is a 6 by itself. So I'm going to go ahead and have that here. And then I'm going to now do this. Now, the length entire thing, we don't know what that number is. They don't tell me. But what I do know that it is 3 combined with X. And how do we represent combining things in math? What math operation? We add. So I'm going to go ahead and add them up. Now, what would be wrong? Don't do this. This is wrong. We're not doing that. And the reason why is because the formula is length times width. So this is addition. We don't want that. We need to have a multiplication indicated here. So the x is getting added to the 3 and the 3 alone. So we do that with parentheses. Okay, so now let's go ahead and go through our steps. So on the left, I can't simplify anything. Go ahead and bring that on down. On the right side, though, I have stuff I can simplify. I have 6 times 3, which is 18, and 6 times x, which is 6x. Okay. And then I'm going to go ahead and start moving things around. So I have 6x, it's positive. So I'm going to move that to the 10x because it's smaller. So I'm going to have minus 6x, and I'm going to have 4x equals 18. And then I could go ahead and divide. Divide by 4, divide by 4. Now, this is not going to be a nice, pretty whole number. 18 divided by 4. 4 doesn't go into 18. It doesn't say to round, so I'm going to leave it as a fraction. So the GCF of 18 and 4 is 2. That becomes 9/2. And so that is the answer.